These notes will consist of what's called sigma notation, and sigma notation deals with series. Now, a series is adding up the terms of a sequence. For example, if I have 1, 3, 5, to turn that into a series, I will do 1 plus 3 plus 5 and get 9. So series basically means to add. So sigma notation, sigma is the Greek letter for summation. So whenever you see a sigma, which is a Greek letter, looks like an E, this is a sigma, it's going to ask you to sum. Now whenever you do a sigma problem, there are some things included. So we're going to add those now. So most sigmas start with n equals 1. They don't have to. They can use different letters. They can start with different numbers, but for the most part, it starts with n equals 1. And that means we're going to start with the first term. And then on top, we'll have an n, and that tells us how many terms. And that number, this right here, will change in each problem. So I don't have to ask you the same amount of terms each time. Then the last thing that'll be included will be right here, and this will be some type of formula. It could be arithmetic, it could be geometric, or it could be neither. So it can be either arithmetic, geometric, or neither. So we're going to take you through a couple problems on how this works. So in our first example, we already have sigma drawn. We're going to add n equals 1 here. And that means we're going to start with the first term. And we're going to do to 3. That means we're going to do 3 terms from first to third. And we're going to do 3n plus 2. So what this is asking you to do is, starting with 1, we're going to plug that in. So 3 times 1 plus 2 is 5. So 5 is the first term. Plus, because sigma means to add, we're going to go all the way to the third term. So we're going to do the second term. So 3 times 2 is 6, plus 2 is 8. So plus 8. And now we want the third term. So 3 times 3 plus 2 is 11. And we're going to add those up. And we get 24. And that is our answer. So when you take this series, you add up the terms to get your total. Now you also can tell from the sequence that since it's going from 5 to 8 to 11, it's adding 3. This must be arithmetic. And you can see the 3 from the formula. We're going to try another example. We're going to put n equals 1 here. We're going to put 4 on the top so you can see the difference. And we'll do 2n minus 1 as our formula for this one. So just so you know, this is the full sigma problem. So this one is asking for 4 terms, from the first to the fourth. So we'll do the first by plugging in 1. And 2 times 1 minus 1 is 1. So this is going to be 1 plus, we'll plug in 2. So 4 minus 1 is 3. Take the third. So that's 5. And I think you can see the pattern, but I'll go ahead and write the fourth. So it's 7. So you're asked to add 1, 3, 5, 7. 1, 2, 3, 4 terms. So let's look. 12, 13, 14, 16. So the answer is 16. And again, you can tell that this one is arithmetic. It's going up by 2, which is where that 2 is. The final problem we'll do is n equals 1. We'll do to the 3, and we'll do 2, 3 to the n minus 1. So this is from the first to the third. So we're going to do plug in 1. So that's 2 times 3 to the 0th, which is just 1. So this is 2. So our first term is 2. Our second, plug in 2. So that's 2 minus 1 is 1. So 2 times 3 is 6. And it wants a third. So 2, so that's 3 squared is 9, times 2 is 18. So you'll notice it goes 2, 6, 18. Well, that's geometric. And it's going up where r is 3. And you'll notice if you look at this, that looks like a geometric formula we've covered. So this looks like it adds up to 26. So when you see a sigma problem, this Greek letter sigma, it is really just asking you to add up. You need to make sure your notes are complete and be ready for tomorrow. There will be a short quiz, one problem, for you to answer once you've finished this part of the video.